We all use data. We all generate data. We all manage data in some way as part of our cognition. We make decisions, and we learn, and we produce, and we work. And so do AI systems. But we must accept that these systems are for now just dumb tools that can make our life much easier. We will discuss what the term easier means in the ethics section, because your easier may not be my easier, but AIs are not sentient and can only harm us if their owners or users choose to have them do so, or if they train on the internet. AIs can be used for good or evil by their owners, and what is good or evil is not clear today. The reason AIs pose no risk by themselves is because they do not have true artificial self-awareness yet. But as we move towards superintelligence, this will come to be a reality because there is a design pathway to artificial self-awareness. But that's not for this presentation. But the future, either good or evil, will depend on data and how it is presented, used, and understood by an artificial intelligence. So why am I rambling on about data? Because the shape of data is critical to AIs, just as it is to us humans. And by shape, I mean the context of data, as it relates to our self-awareness and our perception. It's the same for AIs. Our human perception is created in our minds based on the stimuli of our world, and we respond to it according to our goals, our self-awareness, and everything we've learned. It makes sense that the better the data and our comprehension of it, the smarter and more successful the system will be, whether it's human or AI. But it is a trade-off. We can waste resources with too much data, but lose optimization and efficiency in achieving our goals with too little data. Everything has a balance, even artificial intelligence. Also, garbage in, garbage out, so quality is important. And garbage data is something we humans are really good at creating. Now, AIs need input data, of which a subset is set aside as training data, and some as a goal, and the rest of the data is used for testing. The key is that the input data and the goal to achieve is a representation of the real world, but in a form that the machines can understand and model, such as ones and zeros. Now, words in chat AI are simply an index of numbers to the machine, of relationship contexts that are relative probabilities or weights or proximities, etc. And in image AI, images are pixels and tones and other representations in numbers and math. You can't just feed human text into a neural network and hope it can solve for the goal, like generate an image or follow-up text or response text. Both input and goal data must take a form the machine can comprehend, i.e. numbers, but as we know, we can do a lot with just ones and zeros. Now, you can build tools to do interpretation for this, but if you think about it, to achieve a goal, you will need to think about what data to train on and how that will cause a response from the AI such that a goal will be measured and successful. And that's what I mean by shape. For example, if the goal is to classify, then what data do you give the AI and what does it measure to? It's like being a teacher. You set up a goal, you give some data, you train, and then you let the kids try to achieve the goal. It's the very same type of methodology. Now, data is critical in AIs. Not just the data, but the type of data, how it is structured, how it is represented and implemented and processed. It must flow from the real world into machine language through a problem to achieve a goal. You can't just throw data at it any more than I could stop you on the street and hurl a bunch of random words and images and expect you to know how to respond to me. Unless you understood the words and a desired goal and decide that the goal was positive enough to get you to go figure out what you need to do to achieve the goal, nothing will happen. You won't respond. Or you will in a different way. Now, the more I think about the words I say to you and the structure of those words, then the more efficient our interaction will be and the faster the goal will be achieved. This is exactly the same for artificial intelligence. OpenAI did it, and there's a world of other similar opportunities just waiting for those with access to resources and talent and money to do a lot more than just chat. Now, these are some types of data. Time series data is stuff like prices, ongoing prices, stock market prices, that sort of thing. For big data, we are currently moving to the era of massive data just because of the sheer volume of data in repositories. We use specialized techniques and lots of math to filter or represent such large or mass data dimensionally, i.e., for example, clustering data to extract relationships. And we do this to extract a learning for an AI, to achieve a goal, like answer a text prompt with a semi-coherent response. All that stuff in high school and college, geometry and calculus and algebra and statistics, is finally being used somewhere. You didn't know where? This is where. It's why STEM is critical. Now, step number 1 in AI data management is garbage in, garbage out. So the input data needs to be tidied up, cleaned up. Now, there are many tools on the market to help with these tasks, or you can just call your local data scientist to massage the data. Let's see, labeling and annotation is for supervised learning and data modeling, feature extraction, etc. So where can you get some of these tools? Well, there's a bunch. Every company's jumping on board with AI tools, so you shouldn't have any problem finding. SAP has Analytics Cloud. Microsoft has a bunch of Azure data tools. AWS, is that SageMaker still? I think that's what they use. And then you can go direct into the code, such as Scikit, which is a Python library / plugin for coders to custom build your own tools. All are tools to help in pre-processing and cleaning or transformation of input, training, testing data. Now, this stuff is a bit more customized, but the goal is the same. Create representations of existing real-world data that the AI can use to learn optimal hidden pathways to achieve some goal for the user, be it return text answers to a stimuli or images or music or a resume or a report or action like turning a car to avoid an obstacle. It all depends on how well you model the data in a neural net to train, interpret, measure, and respond to a stimuli for a specific goal or as part of a general response. There is a vast growing need for people who are capable of exploring, visualizing, and creating these representations of real-world data for AI systems, as well as the selection and application of neural net models and functions to achieve specific output goals. These are special skills in deep data architecture and deep learning solutions. They will be far more valuable skills if they are backed up with experience in the dev areas, i.e. in AI or general AI and business expertise. Interpretation is where statistical analysis and math comes into play. It's not just seeing the data and how it can be represented, it's also understanding how it can flow through an AI for benefit. You can think of a hedge trading AI that can search for correlations and arbitrage, not just using data and data models, but math like calculus and algebra and statistical analysis and probabilities and geometry to extract more out of the data. The structure of data also needs to include the structure of the underlying math. Then you layer on top code and code architecture. This is what it means to build an AI. And we'll see this in far greater detail as we proceed through the presentation and into the hands-on labs. Now, visualization often means having an AI plot data so it can be understood more easily by humans. Our human understanding of data is not just about ensuring the AI achieves a goal. It is also the foundation of something we will talk about later, or what some call explainability or auditability, or basically having a method to comprehend how AI decisions are made inside the machine, right back to the input data. Okay, so we'll take a break here and return to take a look at a simple AI model or a simple machine learning model using an open source Python tool called scikit-learn.